All right. So like I said the other day, I post these. If you go on a Canvas, you'll see them starting to get posted with the notes. I put the notes up afterwards, typically. Um, Sometimes people want them before. I don't usually have them before. Usually they're posted on the website afterwards, right? Once everything's written in. All right, so what are we doing? That's kind of the look forward. You got your first homework due tomorrow. It shouldn't be too bad. Um, if you have any issues to how to submit it in MATLAB, feel free to ask. One thing, you can reach out to me in Discord if you want to meet with me one-on-one. Probably the best thing to do is reach out to me, send me a DM. I will be available. I'll go to the study room tonight in Discord for office hours from 7:30 to 9 is what I'll plan to be there. Okay. So you guys can stop by if you got questions. And I don't care. You guys can listen to each other. It's a fine learning opportunity, I think. If you've never done it before, you can ask whatever. You can ask questions about the homework, about life, whatever you want to ask. Right? It's fine. Homework next Friday, then the Friday after, to usual Friday stuff. And then exam one will be that Thursday, September 12th. All right, so we'll talk about the details of that after a little bit later. Okay. All right. All right, so today more MATLAB stuff. All right, so again, it's a little bit old to be reading a book that describes code, but you can look at that in the book. Chapter 3 does have a lot of good stuff on MATLAB. And then eventually, as we go through this, we'll be focusing on a lot of stuff in chapter 4. All right, so if you wanted to figure out which sections of the book are relevant and helpful, it's those ones. Okay, at least for the first part of the class. All right. So today, what I want to cover, I want to cover some basics of MATLAB. I want to talk about how you make graphs. All right. And so this gets into an important concept about the difference between what I call continuous time versus what I call discrete time. Talk about linear algebra, which you guys look like you had all taken, so that's good. And then some other stuff that's kind of code related. If I say looping, what do I mean by looping? I'm talking about code. There's probably other definitions that I don't know, but what's looping mean in terms of code? Yeah. Yeah, there's some iterative process for doing something, right? So you guys did for loops and do loops and stuff like that. MATLAB, like any programming language, has that same capability, right? MATLAB has if statements and all that kind of stuff too, right? So it's just like any programming language. Now, one thing about MATLAB, so I mentioned the other day about MATLAB's an interpreted language, right? And on versus like C's real low level stuff, right? Low level meaning, if I want to manipulate registers and things like that, I can do it. Like I said, if you think C is easier, then I've done you wrong. All right. C is not easier than MATLAB. If you talk about, why is the language useful for one thing? C is useful when I'm trying to do do firmware programming, the actual microprocessor that's controlling a system. That's probably good to do in C. MATLAB's useful to me for manipulating data, right? That's probably one of the primary reasons I'm trying to do it. So, we're going to talk about plotting. So I don't know, we make a big deal about making graphs, right? You don't normally plot a graph of a function or something like that. Like you guys, that's what you guys are used to doing maybe from high school and from calculus, right? Is you'll draw a graph of a function. In reality, when I'm trying to, talk about plotting or graphing, it's because I'm taking some kind of data from the real world and I'm trying to graph that and visualize it and make some sense out of it, right? So we'll deal with that in the project. That's why we focus so much on that stuff, because a tool like MATLAB or Python nowadays is the kind of thing that you're using to sort of make sense of data, right? And that's what ultimately, the purpose of this class is usually to be able to manipulate data and to be able to analyze more complicated sort of systems, okay? All right, so I said we write scripts, not programs. What's a script? You mean to write a script? How's that different than, say, a C program? Yeah. You write commands and it just interprets them one at a time, right? And so when I write a script in MATLAB, I did the example the other day, like usually I have a script file. In MATLAB, that's a .m file. So you may hear me say a .m. That's what the script files are named. You can also run commands at the command prompt, right? So it has a little command prompt and you can write the commands there. All right, so the other day we started going through some basic and important stuff. So vectors and matrices, okay? So let's see if you guys remember here. So what did the semicolon do here? Somebody other than the guy in the red shirt. There you go.
Semicolon makes it so the text doesn't display the window.
The semicolon makes it so the text doesn't display the window. That's right. So at the end of the line here, that makes sure that it doesn't show in the window, right? So this will, so if I did T2 equals that, nothing, and I put that at the command prompt, I wouldn't get anything in the window, right? What about these semicolons, like where it says 1, semicolon 2, semicolon 3? So first of all, this is an array in MATLAB, right?
They started a new line.
Starts a new line. All right. So that turns this into what I call a column vector. So if I looked at, as you guys learned it in linear algebra, right? You would say that T2 looks like 1, 2, 3, like that. This would be T2, right? So that's what I call a column vector. What's the size of that? If I talk about the dimensions of that, what would we say are the dimensions of this? We usually say it's m by n. So what's m? So when you say the dimensions of a matrix, which number comes first? What is it? Row by column, right? So this is 3 by 1, right? What's this one here? A equals 1, 2, 3, 4, 5, 6. 2 by 3, right? So if I looked at this guy, write it out, it would be 1, 2, 3, 4, 5, 6. Okay. All right, we're going to use that form to solve stuff and to deal with stuff. Linear algebra is really honestly the sort of, if you get into big data analytics, data science, and that kind of stuff anymore, linear algebra is really the core of it. Right? It allows us to be able to easily and quickly manipulate numbers. All right, matrix multiplications are a lot easier typically than using for loops and do loops and all that kind of stuff. All right, and that doesn't make sense to you probably, but you'll get used to it. All right, so what happens if I execute the following code? So we did this quickly the other day, but I've got a row vector and a column vector. So when I just have a single row of a single array of numbers, right? So it's a single row, single column, right? I refer to that as a vector. So what would this be? X1 is the sign of T1. What would that be? Would that be a row or a column? Be a row. Why is it a row? T1 is a row, right? So if I looked at it, right, basically the entries in X1 would basically be the sign of 1, the sign of 2, and the sign of 3. And the reason it's that is because this guy is the first entry in T1. So what did I say was the first index in MATLAB? First index number. It's 1, not 0 like you have in C. So T1 of 1 is basically the argument to the first entry of that sign. All right, so if I give a vector to a function, I get out a vector, and it should have the same size. Okay. All right. All right. So we get into plotting, right? Usually when I get into plotting, when I want to visualize data, and I talk about data, usually I'm talking about something that's been measured, right? We'll get to that kind of thing a little bit later in the semester. When I say something that's been measured, basically somehow I measured voltages or currents or something in the real world, usually with a A to D converter of some kind, an analog to digital converter, and I'm trying to plot some data. So usually it's not like this. I got x of t, a pure math function, right? So x is a function of time, and it's 10 cosine 2 pi t plus 45 degrees. Okay, so the other day, we talked about a couple of things, all right, about sine waves and cosine waves. What's the 10? What do we call the 10 in front of that thing? The amplitude, right? And what would be the frequency of this guy in hertz? 2 pi 10 t. What's its frequency in hertz? 10 hertz, which means its period is what? 1 over 10, so 0.1 seconds. That means it repeats every 0.1 seconds. All right, now let's say I want to draw a graph of this thing from negative t, so the negative period, so t we just determined is 0.1 seconds, like so, all right? All right, what do I need to do you think, to draw that graph? What are the steps? What's step 1? Yeah. Yeah, I want to declare basically the time vector, right? So basically I want to figure out what the x-axis is going to be. And then when I take you take the cosine of whatever these x-axis values are, and you get the y-axis values. All right. So how would I do that? Well, so I would make a time vector. I call it t. You can call it whatever you want, but I'll call it t. All right. And I'm going to put it in square brackets. So the way you do that in MATLAB, if I want to create a vector, all right, there's lots of ways to create a vector, but in this case, usually what I do is I give it an endpoint or two endpoints, a starting point and an ending point. Okay. So in this case, I'm going to say I want to start at negative t, and I want to increase in some increment. I'm going to call it INC. That's the increment. That's how much I want to go up by. And I want to go from negative t colon by a certain increment up to t. Okay. So and what I would probably do is the first thing I would probably do in my code is I would say, well, capital T equals 0.1, right? And then I would run this line of code, right, where little t equals that thing in the brackets. I would have to define what the increment is too. I don't know. So let's say the increment, well, I need to define what that increment is. Let's talk about what that's going to be. The next thing I would do is I would say x equals 10 times cosine 2 times pi times t. And then that 45 degrees I would have to put in there as well. But I wouldn't put in 45 degrees, would I? Why not 45 degrees? Everything works in radians. So I could do a conversion, but I happen to know that that's also pi over 4, right? So it would be that. Now, where would that be? So that guy would start at negative t, and it would end at t, and it should look like a cosine in between those points, right? So the thing is, I got to talk about what is this increment? What should it be? All right, so when I talk about an increment, let's just say, let's do something a little bit simple for a second. Let's say I go, just to give you a sense here. Let's say I created a vector n, and I wanted to go from 0 in steps of 0.01 up to 1. Okay. If I looked at what that vector was, what would be the entries in that vector? Any idea? So if I looked at n, the first entry would be 0. All right. And I said 0.01 is the increment. So basically what that says, the way I read that in words is I say start at 0, increase the entries in increments of 0.01, and then stop at the number 1. All right. So what do you think the second entry would be in that vector? 0.01. Right. What do you think the one after that would be? 0.02. And it would continue on until I got to the number 1. All right. So that's what it means. This guy here is the increment. Right. This guy here is the increment. Now, very often in your homework, I'm going to tell you what the time vector is. All right. Why do I tell you the time vector? Because if you think about it hard enough, like when I grade you with those MATLAB problems, right? Like I have to basically tell you what points so that it can check the answer, right? So usually I give you the time vector. But you get the project, for instance, you may have to pick that, right? So you got to be smart about what that is. So what should it be? Well, what it should be kind of depends on, what the details of the signal are. So we're going to talk about that point a little bit later in the semester, right? But if I talk about this, it's important to get it out now. So I want to talk about this concept of continuous time versus discrete time. All right, so that's a more generalized term of something you guys have probably heard about, but maybe don't understand fully, which is the difference between what I call an analog signal and a digital signal, right? All right, there is no such thing as a digital signal really in the real world, right? Everything in the world that was made long ago is analog. What does that mean? I guess I wrote it here. I say continuous real valued magnitude values, continuous real time values. What does that mean if you had to explain it to something? That sounds very mathy. Physical value of something. Well, yeah, I mean, it's true. It's continuous in the sense that it never breaks, right? If I think about a voltage, if I think about my voice, right? There's waves coming out of my voice, right? And they're continuous, like they don't end. If I think about a function, it's real value, meaning so if I look at a function that I plot, how many numbers are there between 0 and 1? Infinitely many. All right. For an analog signal, a signal that exists in the real world, there's infinitely many values. If I recorded my voice and I looked at the voltage, right, there's infinitely many values in that voltage. Okay. However, could a computer record that? If I told you, hey, I'm going to record this voltage and it's analog, and it goes for 1 second. So I measure values for 1 second, so from 0 to 1. Would it be possible to store an infinite amount of values in a computer that go between 0 and 1? No, it wouldn't. So what I have to do is I have to sample that thing and convert it to what I call discrete time. In other words, so the word discrete meaning that I only have values of it at certain points in time. Right? So if I'm reading a signal in the real world, some voltage that means something, what I'll have to do to get it in the computer is, let's say I have a sine wave like this. So if I had an audio signal, it's made up of a sum of sine waves. We'll see that later, right? So if I have an audio signal that I record, I can't capture all of this waveform. I might just capture a point here, and a point here, and a point here, and a point here, and a point here. And if I capture enough of those points, then I'll capture what the waveform is. That's what discrete means. All right, we talk about digital signals. What we also mean, we're not going to touch on that. With discrete values, or with digital values, what we talk about is that these points that I pick off that waveform, I have to round those off as well. Right? I can't pick the actual values off of that waveform and store them in the computer, because how many real numbers are there between 0 and that peak value? Infinitely many. The computer can't handle that either, right? So the computer can only handle, let's say, 32 bits, right? If in 32 bits, there's only so many numbers. I'm not going to deal with this part right now, the fact that the x-axis is discrete, but at the time axis, I'm going to deal with, right? The time axis is discrete, so I need to deal with that fact, okay? So the question would be, I need to figure out how to figure out what this increment is. The increment would basically be the distance between here and here, those 2 points, all right? What's that distance? That's what I'm calling this increment. So I got to choose that wisely, okay? All right, so here's our waveform. This is 10 cosine omega t2 plus phi, whatever that is, all right? This is probably me trying to make, actually it is me trying to make 10 cosine 2 pi t plus phi. So somewhere in my code, I've defined that phi is pi over 4. It's not 2 pi t, it's 2 pi 10 t. All right, so somewhere I defined this was omega, and this phi was 45 degrees, okay? All right. So help me out. Let's understand what this guy is. T2 is negative t in increments of t over 2 up to capital T. So, all right, for my 2 pi 10 t, what was capital T again? The period, what is it? What's the period for 2 pi 10 t? 0.1, yeah, 1/10. Okay. So let's think about our T2. What would be in there? T2 would start at what number? Negative 0.1. All right, that's over here. Okay. And it would increase in increments of t over 2. So that would be 0.05, right? Up to 0.1. So if I think about what that looks like, it would be negative 0.1. What would the next value be? What would be so basically the increment here is I add that values of 0.05 and get to the next one, right? So 0.05 plus negative 0.1 is what? Negative 0.05. What would the next one be? 0, and then it would be 0.05, and then it would be 0.1. So that's 1, 2, 3, 4, 5 points. All right, what I did here, I ran this command here, plot T2 comma X comma O in quotes like that. Okay. All right, now I give you a number of examples of plot here. This is about as fancy as you need for homework one. All right, I'm assuming that you're going to kind of learn some of the stuff as you go. You don't know how to use the plot command? You can, in MATLAB, you can type help plot and it'll tell you about it. You can also type into Google, you can just say, MATLAB plot command, right? And you can easily get more information about it there, right? But if I want to plot this vector, I do that plot T2 comma X. Normally what I end up doing is T2 comma X, and that makes a graph. All right, we're going to look at what that graph would look like. Anybody know what this does when I put the O? Yeah.
Plots all the points as O's.
Plots all the points as O's, right? So, and you can kind of see them here, right? So this one here at 0.1, I get that point right there. I don't know how well you guys can see that from there. All right. At negative 0.05, I get that point here. And then at 0, I get this. 0.05, I get that. And 0.1, I get that. Now, to make a graph of this function, what do you think? So normally, you guys, like, what should 10 cosine 2 pi t look? Well, it should look like this, right? It should have a cosine look. How would you make that cosine look? What would you do between these points if you were trying to make a graph, do you think? To make it look nicer, I'd have to decrease the increment, right? But normally you think of it as looking continuous when you look at it on the screen, right? So how do you think they make it look continuous? I can make a lot of points, right? And I do typically, but what do you think you normally do to just make it look more continuous? Well, we use something called linear interpolation, right? What it does is it draws lines between the points, right? And if it's finely sampled enough, that collection of lines will look nice and smooth, right? So let's take a look at the difference here, right? So basically what I did here, this is the same. I'm going to go back to my code in a second that I skipped over. What I did with these guys here, so I made two different time vectors. This time vector was the one I just did, right? Starts at negative t, goes to t. So in other words, this guy is going from negative 0.1 to 0.1 in steps of 0.05. This guy over here starts at the same point, ends at the same point, but what's the difference here? What's the difference with this one? The interval is way smaller, right? So what's t over 1,000? Well, 0.1 divided by 10 to the third, which is what? 10 to the minus fourth, right? So what's 10 to the minus fourth? It's 0.0001, right? Much smaller jumps between points, right? Now, to draw these graphs, and again, I'm going to go back to the code in a second. What did I do? I basically did plot t comma x. I didn't put that O in there, right? That's what both of these guys are. It's plot t comma x. And what it did is it drew lines, right? That's how we make these things look continuous, right? The computer can't show a continuous thing because you can't possibly ever have a continuous thing. I would have to have an infinitely fine spacing between points, and I can't, right? That doesn't exist in a computer. So what it does, it just draws lines between those points that it has. So does this one even look like a cosine? It does not, right? That is what cosine really should look like, all right? So what's that tell us? Well, there is actually like a theory to this. So in other words, there is actually a frequency, a sampling frequency that matters. And in the first project, we'll deal with this like for sound, right? When you guys are listening to an audio file, when you're streaming audio, for instance, right? You're not listening. I mean, ultimately, you do hear an analog signal that's going into your ear. But if I look at the file that's streamed over the internet, it's digitized, right? I have to make sure that that audio sample is finely sampled enough so that it looks correct and sounds correct when I listen to it. This would sound like garbage. All right, if I looked at this, you could hear this waveform. I could put that into basically a digital to analog converter, and you could hear that, right? This you could hear as well, but it would sound totally different, all right? So this is important. Bottom line for us basically is this spacing matters if we want the waveforms to look right. Now your calculator, your TI calculator is where you probably like it better. You don't have to think about that. The TI thinks about it in terms of what it thinks it should look like. All right. It's much more powerful to have to make you be the human in the loop that has to think about what it is, right? You can do a lot more with a tool like MATLAB, which may not matter to you, but again, it's useful once I get into some real engineering design problems later on, okay? So let's look at my code here for a second, right? For how I did this, all right? So I'm ultimately going to look at a couple of different versions of this. So what did I do? So again, I put this clear all at the top of my code. Why did I do that? What did clear all do? Clears any previous, any variables that are stored in memory, clears them out. Which is good because, you know, I may be expecting a particular thing. Maybe capital T was already defined and I forgot to put it in my code. Well, MATLAB will just happily graph it, right? Because it's an interpreted language, anything that it interpreted before, it's just going to use that value, right? I see people do that all the time. Particularly in the project, you'll get all kinds of wacky stuff because you didn't clear out your variables or initialize your variables. All right, so again, any programs you write, you got to initialize your variables, whether in MATLAB or whatever. All right, so what I did here is I defined a couple of different time vectors. All right, and to actually make the graph, notice what I did here. I did so plot T1 comma X1. So that was going to plot this guy with that time vector. Now that time vector is a really stupid one, right? Negative t in steps of t to t, right? So what would that be? That would go from negative 0.1 to 0 to 0.1. What would that actually look like? Anybody know? It would be a straight line, right? And you can plug the numbers in to figure that out. All right. Here's basically if I ran that code and I looked at all of those different graphs, I get something like this, okay? So let's take a look at what I did here. So I basically what I did was I made 4 different time vectors. What's the difference in the time vector? So T1 goes from negative t in steps of t up to t. If I look at T4, negative t in steps of t over 100 to t. So which one of those has the most values in it? T1, T2, T3, or T4? Which one has the most? What's that? T4. T4. Question?
Yeah. So when you're doing the full-on code, I was in MATLAB. You said yesterday the semicolons or colons they hide the results. So if you send, like, do you need to add the semicolons when you're doing full-on code, or
You don't need to.
so when you sent this, would it show anything?
It would.
Okay.
And depending on whether you had the command window up or not, you would or would not see it.
Okay.
But it does slow things down. If I didn't have semicolons after each of these, it would take longer for me to get to this line of code. Because it waits now. It'll display everything, then it runs this one. It'll display everything in that one, and then it'll do the so which, you know, for these vectors, they're small, but I might give you a data file, and I will give you data files in the project that have millions of lines. Right. And you might wait a while for those, right? To plot out a million values. What's it doing here? T1, X, so say plot T1, X1, T2, X2, T3, X3, da, da. What's it doing?
Plotting the variables.
Plotting all 4 graphs, right? MATLAB can deal with this plot. Again, if you need more information on plot, you can always Google plot, right? I'm not going to teach you the details and semantics of every line. You should be, you guys are smart enough that you should be able to figure that out on your own. But it has basically XY pairs, right? So this is 1X, 1Y, 1X, 1Y, 1X, 1Y, 1X, 1Y, right? What would have happened if I said T1, X1, T2, X2, T3, X3, T4, and stopped there? What do you think it would do? It would throw an error. I can't give it a set of X values without a corresponding set of Y axis values, right? So I got to be careful about that, all right? Now let's think real quick. Which ones, so I drew all 4 of them on top of each other. MATLAB naturally has a color palette that it goes through to figure this out. The first one's always blue. You can add stuff to this to change the colors and things. You know, I'm not requiring you to do stuff like that. Maybe in the project, but for now, I just want you to draw graphs and stuff. So which one's which one's X1? There's 4 graphs there. The line, this is X1. Okay. Which one's X2? This one. Right? The one that goes in steps of t over 2. So this guy here, the triangle looking wave. Now, what about the other ones? Can you tell? By the time I get to X3 and X4, they're similar, but not quite the same. Which one is, do you think, X3? The one with these edges, right? Because it doesn't have it looks a lot more like a sine wave, but still doesn't have enough points to look continuous enough. So it has this gap. So this guy here, this is X3. And then the prettiest looking one here is X4. All right. All right. Again, for now, first part of the class, I'm going to give you these time vectors because it's actually, if you think about it hard enough, it's impossible for me to grade it or have the MATLAB can grade it automatically if I don't tell it. If you use a different time vector than you did, it doesn't have a way to grade those problems. Right. So I will give you the time vectors. So if you go into problem 4, for instance, I think I give you the time vectors. Okay. All right, so again, this is the type of thing we have. I mentioned to look at the book a little bit. You can do stuff like add labels and titles and things like that. You can add a grid. I might tell you to do that kind of stuff. All right. Anytime I'm dealing with a text string, that's when I have these quotes, right? And so what do you think this is doing? X label, Y label. What do you think that does?
I think it's labels to X and Y.
Labels the Y and X axis, right? Fairly straightforward what it's doing. Okay, if I do title, it puts a title on the top of the graph. All right. All right. So again, just some more details on this. Basically, this is 10 cosine 20 pi t, so it's a little bit different. All right, you guys can look at this so you can see some more examples later. I want to make a point. I've said this before. All right, code is always correct. Right, it is. Right, that's an important point. All right, why is it an important point? Because I've blown up a lot of hardware as a result of the fact that the software guy was, I dropped the variable or whatever, and that blew up my hardware. Right, because the code always works. You as the programmer might be wrong, but your code's just going to do whatever you tell it to do. So what's going to happen here? T is what's T? Is that a row vector or a column vector? 1, 2, 3. The row, right? What's X? X is a matrix, and what is X's size? 3 by 3. So if I did T comma X, what do you think it's going to do? It'll make a graph.
There was plot every single.
I think it'll make, actually, I'm not even sure, but I think what it's going to do is going to make 3 graphs, right? It's going to plot the first row versus, so you're going to see 4, 5, 6. So in other words, it's basically like what you did would if you did plot T and then 4, 5, 6 and then T and then 7, 8, 9 and then T. At least we should check. I'm pretty sure this is what it's going to do. So it's going to make 3 graphs. I don't really care exactly what it does. What I'm saying is he's going to plot something much more complicated than you might have first thought if I just looked at plot T comma X. Now, why do I say the code is always right? You're going to come across scenarios, probably in the project, where you might accidentally write that in there because you haven't checked the size of X. You don't know what the dimensions of it are. Which, if it's 3 by 3, no big deal, right? But what's going to happen is you're going to run into something that's 20,000 by 20,000, and then your computer is going to probably go to a blue screen of death sort of situation, right? Because it's trying to make 20,000 different graphs with 20,000 different points, right? That's a pretty intensive thing for your NVIDIA graphic card to try to do, all right? And it will crash. All right, so I've seen people do that all the time, like, oh, I crashed my computer on this. You need to check that it was correct. So I put this here, right? What if I had, 200,000 columns and 200,000 rows? You can run into those problems. In other words, that is executable. It won't give you an error, but it gives you sort of an error because it is going to crash your computer. All right, so the important thing is to check your stuff. Now, one thing about checking your stuff, I'm going to jump ahead and then come back. One thing that's important in MATLAB, there's a command. I have a list of important commands, but one important one is the command size. Right? So if I say, what's the size of X, for instance? The size of X. It will tell me the dimensions of that vector. Right? So if X was a 3x3 matrix, and I did size X, it would tell me 3, 3. So I can check to see what the dimensions are if I'm not sure. I do that all the time just to make sure that I know what's going on. All right, so we're going to need that as we go through. All right, so plotting, right? It's not that complicated. I will give you that kind of that jump, right? But that makes sense. You guys will have questions about it later for sure. Any questions about that? All right. Like I said, MATLAB's really about linear algebra. All right. Linear algebra, what you know is you use that to solve systems of equations, right? All right. So in chapter 5 of the book, you can go into that if you want to brush up on it, right? I think it's really boring. It's really important. We use a lot in embedded design. So as you get into, if you do real embedded systems as a computer engineer, it does matter, particularly if we're trying to do Fourier analysis and things like that, which are really important in a lot of cases. You don't know what that is yet, but we're going to talk about that later, right? But if I need to look at signals and process signals and understand what's in a signal, right? This turns out to be useful, okay? And I'm going to use that term a lot, process signals, right? When I say process signals, if I think about what an electrical engineering system is, or a computer engineering system is, what do? I typically I've got some sensors or something like that, and I'm trying to take data from those sensors, get them into a computer, and use that data to send commands out to motors and things like that. That's really what most systems that we make do, right? And so when I take signals from sensors, I'm processing those signals. So I'm going to use that term a lot, signal processing, right? That's really a lot of what ultimately we end up doing. All right. So in processing those signals, linear algebra is a really important thing. Okay. All right. So where you guys probably learned the need for this stuff, right, would have been with systems of linear equations, right? So if I had mesh analysis, right? So if I did mesh analysis, I would come up with, for this circuit, you should be able to do the mesh analysis for this. I wrote down what the equations are, right? But I want to figure out how would I put this into MATLAB to solve, right? So I'm going to be asking you to do at least one problem like that on homework 2. I ask you to solve some stuff in MATLAB, and I give you a circuit to solve it with, right? So what do I do here? How would I get this into, if I had that system of linear equations, I did my 2111 stuff, I would get to this. I should be able to convert that into that form, AX equals B. So you guys tell me, what's the X vector here? If you remember your linear algebra, what would X be? The currents, all right? And how would you set that up? What would the currents be? Would it be a row vector or a column vector? Okay, column vector, right? So I'd say, most likely, I'd say I1, I2, and I3 like that, right? And so what would the A matrix be? What would be the first row? 10,000, yep. Yep, 10,000, 0, negative 6,000. And then I have I1, I2, I3. And then what would that be equal to? Negative 6, 6, and 0. Like that. Okay. All right. So the thing to remember about this is the first equation right here. How do I get to that first equation from what I just wrote right here? When I do matrix multiplication, I do what times what? So this is a multiplication, right? This is, I didn't finish that, right? There should be 2 more rows in that, right? I only did the first row. But how do I use what's here, and here to get to that first equation? I do what?
Row times column.
Row times column, right? So I do 10,000 times I1 plus 0 times I2 minus 6,000 times I3 equals -6. Right? And then I would do the same thing for the middle equation. And the whole thing would end up looking like that. Okay. So it's always matrix multiplication is always row times column. But back in the old days, I'd probably expect you to do a lot of that stuff by hand, right? There's no reason why, in my view, you should really do that. You should be able to really go into a program like MATLAB and have it do it for you. I know your calculator can do that, all right? But it's clunky and stupid, in my opinion. All right. That the calculator, it would be silly if you screwed it up, you'd have to put it in there like 12 different times. Right. If I put it in a script, I want to get that, drilled into your head. If I put it into a script, it's a heck of a lot easier to solve stuff and to look at mistakes and rerun things if you're wrong. Okay. So how would I solve for I1, I2, and I3, the unknowns here? Row reduced echelon form. For whatever reason, that's the thing that they like to show you all the time there. It's really not what we do all that often, right? Normally what I'd say is if this thing is A, and there's nothing wrong with the whole row reduced echelon form approach, right? But typically we do the inverse, right? So I'd say X equals what? A inverse B, right? And it has to be A inverse B. It can't be B times A inverse. That's a totally different problem, right? And you should have learned that in linear algebra. So if I were to solve this, all right, I'm going to come back to whatever I have here, right? But if I look at the way that I would have taken this thing, so the A matrix, right? So if this is AX equal B, right? A is this guy here, and B is, I don't want to draw those lines, or B is the -6, 6, and 0, right? And then X is this guy, the current vector, right? So I should solve for the currents when I do this operation. So if I look at this here, this is me entering that, right? This is the first row, 10,000, 0, -6,000. I think I have too many zeros there, don't I? Right. 10,000, 0, -6,000, 0, 12,000, -3,000, right? So that's the middle equation. This goes to the bottom equation. Now, what did I do here? What's the semicolon doing? Making new rows, right? What did I do here? B is supposed to be a column vector that's -6, 6, and 0. So what is -6, 6, and 0? The way I wrote that, what is that? It's a row vector, right? This little tick mark, what I call a transpose operator. What's a transpose, if you remember from linear algebra? Swaps rows and columns. You could have done -6, semicolon, 6, semicolon, 0. Totally fine. Right? I was just trying to show you the transpose operator. It's a tick mark in MATLAB. So what's that going to do? B would actually be a column vector. All right. Because of that tick mark. And what did I do to solve for the currents? So I called it I as a currents, not X. All right. I said inverse A times B. So inverse is INV. And MATLAB solves it for you. Okay. All right. So some important commands that we deal with in doing this. All right. We're going to deal with a lot. Right. So ones. Ones is the command that creates a matrix of ones. Zeros creates a matrix of zeros. You're going to need those later. All right. Those are common commands. And then size, I said, basically tells me the number of rows and the number of columns. All right. In a given matrix. And that's usually useful to me. All right. So for this T vector that I made here, apparently it has 1 row and 20,001 columns. Okay. All right. The other thing that sometimes I use is the length command. Like if I know something is a row vector or a column vector, it just tells me how long that row vector or column vector is. All right. Usually I use the size command. Size assumes that it's a matrix. Length assumes that it's a vector. Okay. you'll get used to a lot of this stuff later on, right? If you're not sure how anything works, you can always go to Google it and get get the help page for it. Okay. All right. So I want to do a little bit of, sort of deeper stuff here for a second, right? And I want to deal with, let's say I want to do this operation here. So I want to make a vector y, and I want it to be cosine 2 pi 30t times sine of 2 pi 10t. For whatever reason, that's what I want y to be. And I want to do that for time spanning from negative 0.1 to 0.1, right? So this is math talk here, right? So t is an element of negative 0.1 to 0. That's not a MATLAB vector, right? In MATLAB, if I wanted to find the time vector, I would say, give me a starting point, give me an ending point, and give me an increment, okay? So it should make sense to you guys that this is what I would need to do here. If I wanted to make that vector y, I'd have to make a time vector, right? I'd have to make the t vector. Then what I have to do is make this cosine, then make this sine, right? And then what I have to do is multiply. Now, one thing is I say, but how, right? Well, because it's important. It can matter what I do. So how would you do that? So here's x1 is 2 pi. So somewhere t's been defined. We're going to get to how I defined it. But let's say I got 2 pi 30t and then 2 pi 10t. So I created x1 and x2. Should I say that y is equal to x1 times x2? Why not? That's what I want to make, right? You're right. It's the answer is no, right? x1 times x2 would be bad. Right? This would be a very bad thing to do. But it looks like what I would want to do if I'm looking at this, right? Why is it bad? Maybe. All right. We got to think hard about matrix multiplication here. Yeah. All right. So, yeah, I'll put these in the wrong order. Okay. So if I do this here, all right. So what did I do? I made a time vector. So I said I wanted to multiply these and I wanted to do it over a time from negative 0.1 seconds to 0.1 seconds. So I gave a time vector here. So negative 0.1 to 0.1, and the steps between points in that vector are 0.1 over 10,000. Okay, so they find the space steps. And then I created x1 and created x2. So given that I have this setup right here, what is that t vector? The column, it's a vector, right? So which one is it? A row vector or a column vector? Row vector. All right. And I don't know how many entries it has. I could think about it, but a lot. I don't know, a lot of entries, right? Probably 200,001 or 20,001, I think. So it's got a lot of entries. What would x1 and x2 be then? If this guy is a row vector, what are these? These are also row vectors. Now, again, these are really big. So let's take as an example something simple. Let's say I had a row vector that was 1, 2, 3, and another row vector that was 4, 5, 6. Right? And I did that multiplication. Can I do that multiplication? No. Right? That's problematic because I'm supposed to do row, column. It doesn't work. Right? I need to make sure that I had the same number of columns over here that I had, and the same number of rows over here that I have columns here. Right? That's not going to work for me. That's going to give me an error. Because MATLAB follows the rules of linear algebra. Right? So what do we do instead? Well, what I have here is what I call this dot multiply operation. Okay. The dot multiply operation is what I call an element-wise operation. So it takes every entry in this row vector and multiplies it by every entry in this row vector. All right. So that is an important thing for me to know, because you're going to have lots of cases where you're trying to do this element-wise thing. So just, to follow my example, if I had 1, 2, 3, and I dot multiplied it with 4, 5, 6, what would that be, do you think? What would be the first entry? 4. So I did 1 times 4. The next entry would be 2 times 5, or 10. And the next entry would be 6 times 3, which is 18. That's the element-wise operation. I want to multiply each element in one vector by each element in the other vector and just keep moving forward by 1 each time. Okay. Now, so there's a little bit of an explanation on this. This is, from the book, a similar example. All right. All operations can be done like this. All right. So sometimes I call it element-wise. I think sometimes they call it vectorized. All right. So if you look at the example here, it says I created this function f and g. So f is the sine of 10t, g is the cosine of 10t. F dot divide g, what is that doing? Do you think? F dot divide g. Well, you're dividing f by g, but you're specifically dividing every entry in f by the corresponding entry in g. So so the result, what would h1, the first entry of h1 would be what? Yeah, the first entry in f divided by the first entry in g. Then it would be the second entry in f divided by the second entry in g. And it would just kind of continue like that. Here it says dot. What's that, do you think? Dot caret. Raised to a power. I guess it says it right there. But the caret function commonly is used as raised to a power, right? So this would basically, if I looked at h2, the first entry in that would be the first entry in g squared. And then the next one would be the second entry in g squared. And then the third entry in g squared, right? So we just kind of continue onward like that. All right. So there's a lot going on here, but it's fairly straightforward stuff. All right. So, again, a couple of important things when we're dealing with all this stuff with matrices. If I look at my stuff here, right, T1 and T2, 2 vectors I created. Again, we've talked about this a lot. T1 and T2. What's T2? Is that a row vector or a column vector? T2 is a column, T1 is a row, right? So notice what I'm doing here. So it says T1 of 1. So if I want to access individual elements, right? If I want to access the first entry of T1, I say T1 of 1. Okay. And so what's it return? It returns a 0. Because the first entry is the number 0. T2 of 2, what do you think I'm going to get for that? Well, I guess I'm going to get 4. I wrote it out there. Right? But it's the second entry in that thing. Now, one thing I got to be careful about is what if I have a matrix, right? So let's say I have A is equal to 3, 4, 5, 6, 7, 8. How do you think I get, I don't know, let's say I want to access this number right here, the number 7. How do you think I access that number? A of what? A of second row, second column, right? So it's row number, column number is equal to apparently 7, right? So if I told you what is A 3, 2, what would that be? This would be an error. It's a trick question, right? Why would it be an error? We don't have 3 rows. If I said A of 2, 3, it would be 8, right? Yeah. It's a semicolon. Or sorry, this would be a comma. Yeah, if you're trying to access so what this really is arguments to a function. Arguments to a function are always separated by commas. Okay. And so here's basically an example of that, right? So what I did here for that T2 column vector, I said second row, first column is the number 4. Here I said first row, second column. That doesn't exist for that vector T2. All right. So what it tells me is it exceeds the array bounds. All right. So MATLAB gives you an error that tells you something about what that problem may be. Okay. All right. So it's, again, a lot going on here, but it's fairly straightforward stuff. It's not too complicated to to figure out. Okay. All right. One thing that we also need to think about a little bit is looping. All right, and I'm going through this fast because again, you know how to write for loops, you know how to write while loops, you know how we've done that. The syntax is a little different. If you're not sure of the syntax, well, it's not that hard to look it up, right? You can just Google, MATLAB for loops and you can figure it out fairly easily. Now, a lot of the looping stuff is contained also in chapter 3 of the book too. You can look at it there, right? So, and again, this page 146 to 149 go through that, okay? So I need, for loops. I don't know, maybe it's just me. I don't use while loops a lot, but for loops are pretty common to need when you're trying to process stuff. All right. So in terms of the structure, all right. If I look at this, right? So the for loop, basically you have some kind of, just like C, you have some kind of indexing variable, right? So in this case, for variable name equals from a start value in steps of an increment up to whatever the last value is. All right, so this for loop loops me through some set of operations, and then I get to, it has an end. So for and end. So usually loops in MATLAB have end as basically is the telling it to end. So it's not bracketized or whatever. Basically says for and end. Now, if you look at my code that I write, what you'll see in the code that I write typically is MATLAB it's a colorful sort of thing. So it marks off, certain special things, and it will do special indentation to sort of signify where things are placed within loops. All right, so you'll kind of get used to that. But let's say I wanted to do this operation right here. All right, I want to do cosine 3t times cosine 4t for the time vector that I defined there. So starting at -4, ending at 4, and increasing in steps of 0.01. Okay, so what we just said is if I wanted to do that operation, normally when you think of that operation, as you would know it from your math classes, you would compute that, and that would be this element-wise thing. So normally, an easy way to do this would be to call this guy x1, call this guy x2, and I would do that dot multiply, right, that I just talked about. The other thing I could do is I could do a for loop, okay? I could do a for loop. Now, how would I do that for loop? Help me out to write that code. How would you write the code to do this? Yeah.
And then
What would I do even before I define the time vector? Clear all, right? I want to make sure I initialize everything. But you're right. First thing I would really do is make the time vector. So I'd clear all.
and then iterate through every value in a time vector, multiplying x1 times x2, and then storing the output.
Okay. All right. So what I would, yeah, you're totally right. So if I'm going to do that, again, I want to initialize stuff. So what I want to do is I want to make a vector to store the output. Okay. So I would say x1 equals cosine 3 times t, right? x2 equals sine of, well, cosine of 4 times t, like that. And to your question earlier, I should put semicolons after those probably, or else they'd print out to the screen, right? I would want to create a place to store the output. So I'll call it y. Now, how should I create that? Well, so if let's say I want to initialize it, right? I would want basically an array of zeros or something, right? So how would I do that? Perfect. Zeros, size, t. Right? What size does is it tells me what's the dimension of the time vector. So what I'm doing is I'm creating a vector of zeros that has the same dimensions as that time vector. Okay? Which is what I want. So then I would write a for loop. Okay. Now let's go back. What do we say about the for loop? Right? for variable name equals start value in increments up to the last value. So what I would do is I'd probably say for I equal to what? I'm going to say from 1 in steps of 1 up to what do you think? Size is going to be 2 entries, right? Size tells me 2 things. So that I don't want 2 things because so what am I doing? What do you in C? What do you normally do? You do a for loop. You create like an I. What's that I do? It's an indexing variable, right? It indexes through the arrays. So this guy is an index that I'm making here. So I'll say for I equals 1 to 1 up to the length of T, right? Because length, because that's just a row vector, just gives me 1 number, right? So it's going to say starting at the number 1, increasing in increments of 1, go all the way up to the length of that thing. All right, so the first time I go through this loop, what's I equal to? The first time I go through this loop. So for I equal 1 in steps of 1 up to the length of T. What's going to be the value of I the first time through? The first time through. Oh, it's going to equal to 1. The second time through, what's it going to be? 2. That's going to be 3. That's going to be 4. That's going to be 5 until it gets to the length of T. The length of T in this case is, I think, 80,001. I think if I check the length on that, I think it's about 80,000 points. All right. So what would I do inside here? Well, I would say Y of I equals what? I'm trying to multiply every element in this guy by every element in this guy. Y of I equals what? X1 of I times X2 of I. Don't need a semicolon. I should, or else it's going to do it. It's going to output it to the screen however many times it runs through the loop. And then I end the for loop. Like that. Okay. Just like you would in C. It's a little bit different, but it's pretty much the same. In C, you would have said from 0 in increments of 1 up to the length minus 1. All right. So it's similar, but different. All right. Here's the code that I would have written. All right. Now you're going to play with for loops in the next homework. Right. Fairly straightforward stuff to do. It's not that difficult. Very similar to what you would do in C. Now, I can also have a while loop, right? So what would I do different if I had a while loop? You have a test condition of sorts usually, right? How would I have done this operation? Let's say I did all of this. How would you do a while loop to do the same thing? Yeah. Yep, up until y is equal to the length, I want to populate the output, and then I stop. All right. So I'd have basically a conditional variable, right? So I would probably say, while I is less than or equal to, right? So in MATLAB, you'd say less than or equal to. I think what I do is I'll post for the next homework, basically, links to sort of the common conditional commands and things like that MATLAB uses. But you're going to need all the conditional tests like you do in C, right? So whenever I is less than or equal to the length of T, and then what would I have to have? What command would have to be so this would be my condition. What would I have to have in this list of operations here? I would have to basically have I equals I plus 1. I don't believe MATLAB has the plus plus. I don't think. It used to not. Maybe it probably does. I don't know. It might now. You can try that. I don't think it has plus one. Like C would. One thing I haven't mentioned, what's the percent thing there, do you think? Comment. It's a comment, right? So, and you'll see, like in my code, if you look at, I say the colorization that it does, comments will always appear green, right, by default in the code. Okay. All right. So one thing that I will do, so here's a looping example. I made this graph here of this function. So it's a piecewise function. Okay. Piecewise meaning that from 0 to t, or sorry, from 0 to 0.5, this function x is 3t squared. And then after that, it's 0.75. Okay. And I want to draw the graph from 0 to 1. All right. And I'll give you a t vector that goes from 0 in steps of 0.001 all the way up to 1. And I want to draw x of t. All right. So I want to make the graph that I did here. Okay. So how would I do that? How do you think I would make that graph? All right. So x of t is equal to 3t squared for 0 to t to 0.5. And then it's equal to 0.75 thereafter. So from t greater than 0.5, that's that. All right, and I said the t vector goes from 0 in steps of 0.001 all the way up to all the way up to 1. Okay. All right. How should I approach that? Well, I'm going to make an x vector first. Right? How do I make the x vector? First of all, how am I going to populate this thing? I've lost you guys. I've covered too much. How do I make this x vector? What do you think I'm going to do? I'm going to loop. Make the for loop. Right? So just like I did before, when I used the for loop, what did I do with the output of that for loop process? What did I do at the beginning for that output? What did I do previously? Yeah, define something to hold the values, right? So what I'm going to say is zeros, which creates a matrix of zeros. And I should say it has the size of t, right? Right. Now, what am I going to do then? I'm going to make a for loop, right? And, I can use any value I want, but I'm going to use an indexing value I, and I'm going to start at the number 1. I'm going to increase in increments of 1 until I get to the length of t. And then eventually end it. Now, what would I do inside that for loop? Well, I want to do those calculations, right? I want to do 3t squared or 0.75, right? How would I know which operation to do, whether it's 3t squared or 0.75? I need an if statement, right? I need an if statement. So what I would do here is I would say, how would you approach that? If, and then MATLAB has an else, and it has an end, I think, as well. All right. I would have an if, an else, and an end. All right. We could talk that through, but I'm not going to. I'm going to let you figure that out for the homework. All right. That's something you should be able to figure out. But basically, I should be able to check to see if the time is below 0.5. Then I do the first thing. If it's greater than 0.5, I should do the second thing. Okay. That's what you guys can figure out in the homework. You got some stuff similar to that to get you sort of more experience with the code. All right. All right. And remember, your homework is due tomorrow. And I will be on Discord in the study room tonight.